All right, welcome everyone. Let's get started. So welcome at today's live webinar about enterprise-wide data exchange going from Kafka experiments to a centralized Kafka. You can go to the next slide, Jeroen. So your hosts for today are, first of all, myself. My name is Joey. I do marketing at Axual. And at the other end of this screen is sitting Jeroen. He's the CEO and founder of Axual. Hi, Jeroen.
Hi, good afternoon.
So let's have a look at the agenda for today. So first of all, we're going to discuss the journey of event streaming within enterprises, like going from Kafka experiments to centralized Kafka. Then we're going to briefly talk about how Rabobank scaled Kafka to 150 plus Devops teams. And we're going to end this webinar with a live demo of Axual's Kafka platform, and we're going to do a short Q&A at the end. And that's it. That's it from me. Over to you, Jeroen.
All right, thank you, Joey, and welcome everybody to this afternoon's webinar. So yeah, today we're going to look at the typical journey that enterprises are traveling with event streaming in their enterprises. And to do that, we are going to use a maturity model for event-driven architecture that was published some time ago by Gartner. And this maturity model is really kind of like the stages through which enterprises are going in getting more and more mature around using events and event streaming in their organizations. So it really starts on the left-hand side with incidental usage. Nothing really arranged around events. It's events coming from, well, some sources, but they handle them individually. Applications handle those sources individually, and there's nothing really centrally arranged for doing events. Then at some point, there's a stage in which event brokers are introduced. After that, you get to a stage where you get centralized event brokers, and after that, it becomes more and more advanced and pervasive to use events. So let's see how these organizations are traveling through these phases. First off, of course, organizations have started processing data a long time ago, way before events were even recognized as a thing. So let's look at the age before Kafka was introduced. And this is really the age where enterprises, they get bombarded with data from all different sides. And this has been happening over the past decades with an increasing amount of customer channels emitting information, websites, call centers, shops, storefronts, all sending information to the enterprise. But at the same time, they're trying to communicate with their suppliers and their business partners, things around inventories, prices, status updates, deliveries, locations. I know this may feel a little bit like logistics oriented towards consumer marketing, but this is much broader because you can have business partners in any kind of area. This is just to illustrate a typical set of events that you may get shot at your enterprise. There's also a lot of internal data sources, sensor information being picked up in your business processes, smart meters being read, applications doing a lot of processing. Think of transaction processing or order processing. And of course, you have these BPM systems that are executing business processes and are emitting information, for example, when a process step is completed. And of course, you have all these public data sources that you can get information from, social channels, news channels, weather sites, broker information from market brokers, and of course, governments that are keeping track of citizens' addresses, pipelines under the ground, anything that they keep track of that you can get updates from. And enterprises have developed, well, like a three-step process in which they generally ingest data and process the information. The first step is to really ingest it, to make sure it's understandable. It gets translated from an external data source into an internal format, ready to be processed downstream. Then some logic is applied. Typically, this is the phase in which data warehouses start to calculate reports, or data cubes are being formed and set up. And as soon as that information is processed, it's the decision makers that can weigh the different options that they have. They can make decisions and they can plan and act accordingly. Typically, this process has been speeding up over the past years, leading to the need for data streaming. And typically, the challenges are many. The number of data sources have been increasing. The volumes of data have been increasing. The frequency of ingestion is definitely increasing, where you used to get away with ingesting data once or twice every day. Nowadays, it's a continuous process that goes on 24/7. And of course, the speed of data processing is increasing. Customers not only expect you to process their request right away. If some sort of straight-through processing is possible for their request, they expect that to happen. So that means that there's an increasing need to start processing data as soon as it gets in. And this is really where event brokers are playing a crucial role. So more and more organizations that deal with events are then moving to the brokerage phase. And this is the phase in which there's a central broker taking care of some of the information exchanges that are happening. And when organizations when they find out that they need an event broker, what we often see is that they immediately start to look for the streaming technology first. Now, if you look for streaming engines, the technology options that are available, there's a multitude you can choose from, but basically there are three categories. You can go for SaaS building blocks being offered by the big cloud vendors. There are open source options, and there are proprietary options to do your event processing with. Now, this is not an objective list, I must say. This is feedback that we get from customers that are considering all the different options. And we haven't even worked with all of these packages, so this is really not objective. But what we do see is that in more and more cases, people are choosing for Apache Kafka to become their preferred engine of choice for handling data streaming, their preferred event broker. But then the teams that start to implement Kafka, they also run into challenges in this phase. And these are mostly technological challenges. Getting to know the Kafka technology, which can have quite a steep learning curve, setting up a robust platform, especially maintenance day 2. It's okay to set it up, but maintaining it and being able to answer any questions that may come in from the usage, that's another thing. And there's quite a complex set of failure scenarios that you have to become aware of to be able to support this technology in to its full extent. Now, in organizations that are deploying Kafka in different teams, sooner or later they find out that if all these teams are deploying Kafka and maintaining it by themselves, then sooner or later it becomes more and more useful to look at centralized scenarios. And this is the next phase in their maturity, setting up a centralized event broker system, a centralized event system, through which multiple teams can connect to other teams. So you get a picture like this. Moving to a centralized Kafka, you have this Kafka in the middle with all the departments of an organization basically around that central Kafka. And we draw organizational departments here just as an example. In reality, it's even the applications of those departments that are connecting. But it's really a lot of different business areas. It's a lot of different skill sets that are coming together, all to exchange business events at this level. But as soon as you start to devise a centralized Kafka, then you will automatically also run into other personas around you that have to deal then with your centralized Kafka, and they immediately start to ask questions. And typically, you run into personas like these, such as a data owner, who, if he's going to share information on a centralized Kafka, then that person had better make sure that they are in control of the data. Because at the end of the year, there may be some regulator or there may be some reporting to do. And this data owner has to answer to the fact that, no strange things have happened to data in the past year. So how can we give the data owner control of the data produced on this central platform? An IT architect, maybe from some other team, not involved with event streaming himself, but it's all fine with connecting to any kind of integration platform as long as it's future-proof, it's proven, and it has a good security track records. Then you have developers that are requested to hook up their applications to the central Kafka, and they want to be sure that they can develop their applications in such a way that nobody interferes with their execution of their own backlog. So there shouldn't be a centralized Kafka team that everybody depends on, through which they need to deploy topics or they need to request authorization to access a particular topic. Operators, of course, they want a predictable and maintainable platform. And then you have procurement that says, well, it's all nice that you selected an open source component. Apache Kafka is open source. But at the end of the day, if things go south, then I still want a credible vendor behind the platform so that I can fall back on that particular vendor. Now, typically, these would be the high-level needs that you run into. And if you explode these needs into requirements, you get typical requirements like these. So a data owner would be looking for data governance, data lineage, GDPR compliance. Architects would be looking for hybrid cloud, for data replication across different areas, across different Kafka clusters, security architecture, etc., etc. And it's typically, if you start to delve into these requirements, that you find that Kafka really supports only a few of these out of the box. So of course it does support streaming technology. It's built, for this streaming purpose. So it is the core of the streaming technology. There's a lot of vendors around Kafka, so plenty to choose from. And Kafka itself can be considered to be already a proven solution. But all of the other challenges are not solved by Kafka out of the box, which means that the central team still has a lot of challenges to solve when moving to this centralized Kafka. Often they end up building their own governance mechanism. Setting up foolproof security can be quite difficult. Providing a self-service environment for the teams that want to hook up to Kafka, and supporting the whole Kafka stack may become a big challenge as the scope of the whole Kafka platform is growing. And then finally, if they do overcome these challenges, then you see the organization moving towards the more advanced stages of event-driven architecture. It's the Kafka everywhere. And then you have a multitude of applications that are exchanging events as if it's the normal, most normal way of data exchange. There's documentation all around. It's just one of the regular integration patterns. The challenges then for the central Kafka team is well, they're not technical anymore, they're really organizational. It's to help define these organizational standards, to start to govern the Kafka catalog, so the topic catalog. There may be a schema catalog that need governing, to help teams in onboarding as fast as they can, and to really scope or to really handle the scope of the entire Kafka ecosystem. Now, all of this has been recognized by Axual some time ago, that organizations go through these phases. And this is exactly why we set up our platform. So what is Axual? It's really a ready-to-go streaming platform for enterprises. It's built on open source Apache Kafka, So we're 100% Kafka compatible. We support multiple Kafka clusters in a constellation if necessary, allowing you to exchange information between different Kafka clusters in different geographies. It's a multi-tenant system, so you can have multiple parties coexisting next to each other on the same Kafka environment. The security is, of course, there. I'm going to show you in a minute the self-service interface, which provides all kinds of features to DevOps teams that want to connect, but don't necessarily need to have all the technical knowledge on Kafka itself. So before going to that demo, how to position us. Sometimes we get asked the questions, what are you to Kafka? I think what we are to Kafka is what Red Hat is to Linux. So we take open source packages off of the internet, we compile that, add management tooling on top, and provide it as one big installable package for organizations to use. Now, if you position us on the maturity model, we would probably, be a little bit too bloated in terms of features for the brokered phase. So we see many organizations that have experimented with Kafka a little bit, but now want to move to a centralized Kafka to approach us. Because as soon as you do, you start to get the need for the features that we have in our platform. And those features would be, in fact, all of the requirements that you just saw of the different stakeholders. We've compiled the whole package around Kafka to be able to fulfill all these requirements for a big organization. So how do we do that? Basically, we divide the platform into 3 layers. There's the runtime platform at the bottom, which is really VMs with Docker or Kubernetes. Nowadays, everybody installs on Kubernetes, so that is like the main platform of choice. We do configure Kubernetes, but we don't provide it. We just expect it to be there either at our customers or in a cloud environment. The 2 layers on top is the set of components that we provide along with Kafka. First one being the streaming platform. This is like the technical layer of our system that deals with Kafka clusters. If you have a single cluster installation, it's a fully automated setup. If you have a multi-cluster installation, it's also an automated setup, including the message and offset synchronization that we do in the backend. And at this layer, there would be a technical maintainer that does all the operations. So this is typically a Kubernetes operator, somebody with Linux or command line knowledge that is able to monitor a system and to restart components if necessary. This person does not get involved with any data definitions, topic definitions, and so forth, because those are completely offloaded to individual DevOps teams that can log into self-service, and they can define their own piece of the pie of the whole Kafka platform. That's something I'll show you in a minute. Of course, these teams, they do produce and consume using their applications. These applications, they do interface with the technical interfaces of Kafka. There's no modifications there. It's 100% open source Apache Kafka compatible. But behind the self-service interface for DevOps teams, we also have a REST API that allows you to configure the platform from any CI/CD pipeline or from any GitOps tooling that you may have. And together, well, these 2 layers are what we consider to be an enterprise streaming platform. You can have a streaming platform, to provide you the streaming, the moving of data from A to B, but it's really the data governance layer that completes the whole enterprise streaming platform. And one of the example use cases that we indicated we were going to discuss today is the Rabobank, which is a top 3 bank in the Netherlands. Rabobank has about 8 million customers that they serve on a daily basis. They wanted to move to being 100% digital some years ago, and to really become a real-time bank. So what they defined is an internal system called the business event bus, which was defined as a solution where things that happen, events, can be captured from anywhere and delivered anywhere. They set out to create this platform, which is based on Axual platform today. If you look at the graphs on the left-hand side, the graphs, they start in 2018. This is where we introduced Axual self-service at Rabobank. And the right-hand side of the graph is last month. And you see that in the past 3.5 years, the usage of the platform has really gone ×7 and ×8. So there's a big uptake of the streaming platform within Rabobank. Currently, there are over 330 different streams in production, over 1,250 streams in dev, test, and acceptance. And this is really where the collaboration shines, because it's over 150 different teams working together around a central Kafka platform. During this growth, the maintenance team that is supporting this Kafka platform was shrunk from 6 down to 1 FTE in 2021, and currently it's even at a half FTE in 2022. So this is really a great example of what skill you can grow with for a central Kafka in an organization. And now, without any further ado, let's go to small demo. So here I'm logging into Axual Cloud, which is the SaaS version of Axual platform that we provide to customers. Let me show you around a little bit. This is a dashboard where I have some open tasks. I will skip that for now. One of the first things that we started doing in Axual platform is to set up a topic catalog. Because of course on Kafka you have a publish subscribe platform. So if data is already on the platform, it would be good for others to know. So browsing the catalog is a crucial part of being able to advertise what data is already on the platform. So let's look at an example. This is an example data stream defined. It's transactions of a non-existing bank. There is an owning team defined here, and there's a key and a value type on this topic. A retention policy is set, and you can see that there are, this topic is being deployed in different environments already. Now I said there is an owning team, team 1 in this case. You can see that I am part of team 1, which gives me the rights to modify this topic. So you can see here that I'm able to edit its properties. And I can also deploy it to certain environments by using simple configuration windows. And here around this topic, you can see that there is currently 1 producer authorized to access this topic, and there are 2 consumers consuming from this topic. Now, since I am part of the data owning team, team 1, I also have the rights to award or to revoke any access rights for applications. So supposedly I want to remove the rights for this application in production. I just removed the access rights for this application, and everything on Kafka is now automatically configured in such a way that this application no longer has access. I can also go directly back to the application catalog. This is a list of all the applications registered in the system, along with their security credentials. Here you have the same ownership rights. So if I go to the application I just revoked the access for, You can see that there is also an owner team associated with this application. In this case, it happens to be the same team, but it's up to the organization and the use case to define different teams for the topic as well as for the application. Here you also see that there's a pending request to get access to some stream for this application. There's another stream which is already authenticated, authorized, I must say, because you see the arrows moving and the color is purple and not grayed out. So that's an easy visual representation of making sure that everybody knows that the authorization has been given. I can also put in a request to regain access to the topic I just revoked. Now I'm requesting access on production. You can see it's already approved in acceptance. I can request this access and go back to the respective topic. You can also see this access request is now open. It's not approved just yet. And as soon as I approve this request, then it's approved. The arrows start to become animated. The request is approved, and everything on Kafka is automatically set up for you, allowing you to continue streaming where you left off. So this is the typical way in which data owners and application owners can interact on a large scale to get access to particular data streams. Now, there's plenty of other things that we cannot cover in this half hour, so I will run quickly through a few of them. But we support the whole software development lifecycle, so you can have multiple environments to coexist next to each other on the same Kafka cluster. So this allows you to have production, development, acceptance, all on the same cluster. But if you want, you can also separate these across clusters. So you can have development and acceptance, for instance, on a DTA environment, a dev test acceptance environment, whereas production can also be offloaded and deployed on some other production Kafka environment. This can be flexibly set up, allowing you to really physically separate DTA from production in practice without developers having to notice that if you deploy something in dev, it goes to a different Kafka cluster than when you deploy something in prod. That is something that is then taken care of under the hood, and you don't get to be bothered with that in this self-service environments. There's full control of your users and your groups. This particular tenant happens to have a list of users in its database, but normally we would hook this up to any IAM system of the organization, being an Active Directory, an Azure AD or something else. And this is like a list of DevOps teams that you can define in your own organization as well. We already saw team 1, so let's look at the Connect team, for instance. You can see some other people being defined here as being part of this group. The ownership works in such a way that if you are part of the group that owns a particular topic, or if you're part of the group that owns a particular application, you get to modify its properties. And then finally, this is something for cloud customers only, but finally, if you are on the cloud, then you would also have like the cost overview. I don't know why this is taking so long, but it used to be faster. There it is. So in cloud, we have a pay-per-use system where we really bill on the metrics and not on the amount of Kafka or Kafka clusters that you use. So here you see the amount of stream configurations being topics deployed. Apparently in February, there wasn't anything produced just yet here. Otherwise, you will see those graphs here. There's a number of groups, authorization groups, so it's typically related to the number of users in the system. And we're also able to deploy connects and connectors for you. And if you do that, we also charge on the amount of connector hours that a connector runs. And of course, there's like a full history of all the previous months, so you can always look back into the statistics of the months before. All right, that is it for the demo. So with that, I would like to close off this presentation and see if there are any questions for us.
Yeah, thank you very much, Jeroen. I already see a couple of questions coming in, so please keep them coming if you have any questions. We will try to